Alright, for section 4.8, you have a handful of story problems that'll probably give you a little bit of trouble. I'm going to show you three that are very, very similar to ones that you'll have in the homework. The first one I'm going to do is very similar to number 33, other than the numbers are changed. So you can read along. It says a surveyor wants to find the distance between points A and B. The bearings from A to B are north 48 degrees to the west, and the surveyor walks 38 meters from A at point C. So they're saying this is 38 meters. And it says the bearings from C to B would be north 71 degrees to the west. It wants you to find two things. It wants you to find the distance from A to B, and then it wants you to find the bearings from A to C. So again, almost identical to what you have in problem number 33. So what I suggest, anytime you recognize that you have a right triangle, and it's, I guess even if it's not off kilter, but you notice how it's kind of off kilter, what I like to do is I like to draw a rectangle around it, and I like to label as much information as I possibly can. Now the reason I draw a rectangle around it is because then I know I've got a bunch of 90-degree angles. And I should be able to play around with this and find a bunch of information. So I'm going to label the couple things that they gave me here. It said that the bearings from A to B is north 48 degrees to the west. So if I drew a vertical line here, north 48 degrees to the west, they are saying that this is 48 degrees. And then if I look at the second part of this information, it says that from C, so drawing a vertical line, which would be this one right here, from C, it's going to be north 71 degrees is what this angle would be to the west. So double check first of all to make sure that when you read that you can set up that. In the book they give you the picture. I don't think they give you those angles, but double check to make sure that you'd be able to set up those two angles. Alright, now that I've got those two, like I said, I'm just going to run through and use all the right triangles. I'm going to start filling out as much information as I can until I get some information that'll help me. Realize what you're looking for. I'm looking for this distance here. So I have one side of a right triangle. I either need to know one of these two angles or I need to find that side length. So like I said, I'm just going to play around with this thing until I run into some information that's actually useful. So for example, if you look at this right triangle, that's 71 degrees. Well, that means these two added together have to equal 90, so this little angle here must be 19 degrees. If I take a look at this being a right angle right here, if this is 48, that means this must be 42. Which means if I now look at this right triangle, there's 90, there's 42. That means these two have to add together to give me 90. That means this must be 48. And now if you look at it, I know that this is a 90 because I made a rectangle. Here's 48, here's 19. If I take 90, subtract those two numbers, 48 and 19, I'll end up with what this angle is. And of course, if I know what that angle is, then I know all the angles on that triangle. And this angle would eventually give me 23 degrees. So now I'm going to pull that triangle out over here. If I have a right angle, I know this is 38, I know this is 23. I don't even need to know that angle, but of course these have to add together to give me 90, so this would give me 67 if I wanted it. I'm looking for that side length. I can use my SOHCAHTOA stuff, my tangent, sine, cosine, whichever trig function I want. Let's say I want to use this angle. Well, according to that angle, I have the side opposite. I'm looking for the side adjacent, so I would want to use the tangent. So I'm going to say the tangent of 23 is going to equal 38 over x. And now I just have to solve. If I multiply both sides by x, there's going to be an x over here. I would eventually want to divide by the tangent of 23. And so now I'll pull out my calculator and I'll type that in. Make sure you're in degree mode. We should be. But I'm going to type in 38 divided by the tangent of 23, hit enter, and it tells me that that distance is approximately 89.5, and we were talking about meters. So that distance is approximately 89.5 meters. So again, anytime I have a right triangle, especially if it's off kilter like this, I like drawing a rectangle around it and just filling out as much information as I can until eventually I get an angle that I want. Had I kept doing this, like this is a 90 right here. If this is 71, then I know that this must be 19. I could continue to start filling out information. If this is 48 and this is a right angle, then I know this must be 42. And if this is a right angle, then that must be 48. And then eventually I can find this angle. So I mean, I can keep going until eventually I'm going to find something I want. All right, let's go back to letter B then. It says find the bearing from A to C. So they want me to start, here's A, here's C. I want to know what is that angle. Well, we actually kind of found it when we were talking before. Since we know that this is north 48 degrees to the west, this would be north 42 degrees to the east. So for part B, it's north 42 degrees east. It can be a little confusing, but hopefully you're able to follow that. If not, you're always welcome to come in. See if you can apply what we did here to number 33 and see if that'll help you out. All right. Problem that gives everyone trouble for the most part is number 34. This isn't number 34, but again, it's very similar to number 34. It says two towers are 40 miles apart. Forgive my drawing. Here's Tower A and Tower B. Where A is due west of B. It says a moose, which is right here somewhere, is spotted from the two towers, and the bearings from A to B, or from A and B, are east 21 degrees north, which is giving us this little angle, and then west 42 degrees to the north, which is giving us this angle. And you'll look at 34, they give you the picture exactly like this. It says find the distance D, which is this distance here. All right, and what I have to kind of recognize when I look at this is I think we can easily see there's a right triangle here, and then there's a right triangle here. What I notice in this problem is that those two right triangles share the same side length, and it happens to be the side length I'm looking for. What that kind of tells me to do is it tells me to use a system of equations to solve this. So what I'm going to do is I'm going to just look at this one for right now. Now, in order for me to set up some sort of sine, cosine, tangent stuff, I need to know that distance. I have no idea what it is. So what I'm going to do is I'm going to call this distance x, and then since the whole thing is 40, this will be 40 minus x. And now looking at this triangle, let's pretend like I don't know how to find that. Using the 21 they gave me, I have side opposite, I have side adjacent. I can say the tangent of 21 degrees is equal to d over 40 minus x. Alright, and that's wonderful and it's great, but I have two variables here. And normally if you have an equation with two variables, you can't really solve one of them. Imagine if I had that equation, I said solve for x. So I don't know what it is unless I know what y is. So the trick is, if you had something like that, remember when we solve stuff like this, now if I have two equations with the same two variables, well, then it's like a system of equations. I can try to eliminate the y variables by multiplying everything by 2, solve for x, and then back substitute. That's the idea I want to use. I've got an equation with two different variables. I need to come up with another equation with the same two variables, and that's going to require me to look at this triangle and do the same thing. I've got the 42 degrees, so what if I said the tangent of 42 degrees was equal to opposite, which is d, over adjacent, which is x. And now what I can do is I can easily solve for d and then substitute that in for d up here, or I could solve for x if I wanted to and substitute in here. Doesn't matter. So let's say I pick this one and I solve it for d, since it's pretty easy to solve for d. Cross multiply, I'm going to say that d is equal to the tangent of 42 times x. And now I can take that and substitute it into this equation, and of course that'll get rid of all the d's. So again, if you need to rewind that and kind of run through that again. Again, how I know to do this is that I have two right triangles, they share the same side length, and it happens to be the side length I'm looking for. That's what kind of tells me to do this. Alright, so I'll run through the calculations again. Yours numbers will be different, but it's very similar in terms of how you do it. I have the tangent of 21 is equal to, d now we said is the tangent of 42 times x divided by 40 minus x. At some point I'm going to have to pull out a calculator. I'm going to cross multiply. So I have the tangent of 21, whatever that number is, times 40 minus x is equal to the tangent of 42, whatever that number is, times x. And so I'm going to pull out the calculator now and help us do some of these calculations. So tangent of 21 is going to be, and like I said, I would probably go out 4 decimal places. So 0.3839 times 40 minus x is equal to the tangent of 42. And again, going out 4 decimal places is 0.9004x. I'll go ahead and distribute. So 0.3839 times 40 is equal to 15.356 minus 0.3839x is equal to 0.9004x. So all I did is I figured out what those two were as decimals, and then for this one I distributed into that quantity. And now I know it doesn't look anything like 5 minus 3x equals 6x, but it's the same thing. You have two x terms, you need to combine them or get them on the same side. So I'm going to add the 0.3839 to the other side. So if I have 0.9004 and I add 0.3839, hit enter, looks like I have a total of 1.2843x on the right side. Left side I still have the 15.356. And then of course I want to divide both sides by 1.2843. So 15.356 divided by 1.2843, hit enter, and I'm going to figure out that x is approximately 11.9567. And we were talking about miles. And now what most people are going to do is say, okay, I've done all this work, I got my answer, thankfully I'm done. Well, not quite. I didn't do anything wrong necessarily, but I said that x is equal to 11.9, let's say, or 12. That's what x is. That's not what they asked me to find. They asked me to find d. I need to know what that is. Well, if you look right here, either one of these two, whichever one you want to, or this one I guess actually would be better yet, you can easily plug the 11.96 in here to figure out what d is. So I'm going to do that. I'm going to take that 11.956, I guess I shouldn't have cleared it off my calculator, 11.9567, and I'm going to multiply that by the tangent of 42. And that will give me the d, the number I'm looking for. And it looks like d, the answer I actually want, is approximately 10.76586 miles. You don't need to round the final answer. You can round it to 1 or 2 decimal places. If you want to go out that far, you can. Now, to prevent you from doing all this work and then end up giving that for an answer, because it's a common mistake to do that. It's a lot of work that you did. You probably figure you're done. When I did my substituting, I could have solved for x and then plugged it in here. So I could have, for example, put x over here, divided, and said that x was equal to d divided by the tangent of 42. That's a little more messy, but that would have given me the right answer right away. Again, that's exactly what 34 is going to look like in terms of your solving, so if you need help, see if that'll help you out. Last one is just another example of a story problem. It says an observer in a lighthouse, again, forgive my drawing, it's going to be right here, is 350 feet above sea level. And it says that they observed 2 ships directly offshore. The angles of depression from the ships, now remember angle depression, if the person's looking horizontally, depression would be downward. Angle depression are 4 degrees and 6.5 degrees. How far apart are the ships? So this angle depression is 4 degrees to this ship. Angle depression to this ship is 6.5. And it's asking how far apart are they? And so you could look at this particular triangle if you wanted to and say, maybe I'm trying to solve that triangle. Or maybe I do something like this and look at that right triangle. Maybe I do something like this again, look at that right triangle. You can make a couple right triangles. It kind of all depends on what you're looking for. Now, if I look at the triangle that I drew here first, notice this entire angle is 6.5. This is 4, which means this tiny little sliver of an angle must be 2.5 in there. I kind of follow that. I'll draw that triangle over here so you've got something else to look at. So I'm saying that this angle is 2.5 degrees. Alright, other than that, on this triangle, I don't really know a whole lot. I know that this distance is 350. I'm trying to figure out what this distance is. So chances are I probably want to come over here and look at some of the right triangles if I can. So for example, let's say I do that. Let's say I looked at that right triangle right here. In other words, I'm looking at this right triangle. Well, if this whole thing is 6.5, this is a 90-degree angle. I should be able to take 90 minus 6.5, and I should know that this is 83.5 right here. So that angle there is coinciding to this angle. And that makes sense. This is not a full, if you added those two together, it's not a full 90. I'm missing 4 degrees, and that's what's over here. Obviously, it's a hand-drawn picture. It probably doesn't look like it, but that's what the angles end up being. Here, let me rewrite this. It looks messy. All right, so 83.5 degrees is right there. Why is that helpful? Well, I can actually find that side length now if I want to. Trying to figure out as much of this triangle as I can to help me figure out that missing side length that I want right here. So, got a right angle, got this angle, got 300, I'm looking for that side length. According to this angle, I know the adjacent, I'm looking for the hypotenuse, so I'm going to say the cosine of 83.5 is equal to adjacent over hypotenuse. And then I'll solve, cross multiply, bring the x over here, divide both sides by the cosine of 83.5. Type that in my calculator, 350 divided by the cosine of 83.5, and I'm going to find out that that length there is 3091.785. So I'm just going to draw this out again. So this is 3091.785. I know this angle is 2.5. Again, I'm looking for this side length. And you might say, okay, well, do I have enough to use the law of sines? Possibly. I've got that side length, or I've got that angle, I guess I should say. I'm looking for that side length. That's good. That's what I need for the law of sines, angle and side across from it. If I'm going to use this side, I would need to know what this angle is right here. So I can ask myself, do I know what that angle is? And I actually do. If I'm looking for this angle right here, remember your alternating interior angles. This is getting a little bit messy. I hope you can follow this. But if I look at this line, they're parallel. If you remember your geometry, when you do something like this angle is the same as that angle. It's 4 degrees. So I actually know that this angle is 4 degrees. Again, it gets a little messy when you're looking at all this. Hopefully you're able to follow that. And if I know that that's 4 degrees and I'm looking for, let's say, this side length here, which is what I am looking for, I have an angle, side across from it, angle, side across from it, I can use the law of sines. I can say that the sine of 4 degrees divided by the side opposite, 3091.785, should equal the sine of 2.5 degrees divided by the side opposite, which is z. Trying to solve for z, it's in the denominator, so I would probably cross multiply right now and say z times the sine of 4 is equal to 3091.785 times the sine of 2.5. And now the calculator is going to come in handy. So let's type this in. Sine 2.5 times 3091.785. There's the number on the right. It's 134.86176676. Sine of 4 is what I need to divide by. So we'll divide that by sine of 4. There we are. And we end up with 1,933.3. And that is my final answer. It is z is approximately 1,933.3 feet, I guess is what we were working with. So again, a little messy in terms of the trying to draw in here and look at all the information. But notice how I used right triangles to help me do it, and then eventually I used the law of sine. Since this particular this triangle right here is not a right angle, I have to use, that triangle there, it does not have a right angle, so I have to use law of sines. I can't use sine, cosine, and tangent. Again, good problem to look at. I suggest that you maybe go back and look at all of these a couple of times just to follow, see if you could go through and set that up, say that that happened on the test. If you're having questions, we'll still have time to look at a couple in class, and you're always welcome to come in and ask for help.